introduction, what we discussed yesterday, or probably you're going to ask any question? No? Okay, good. So today we are going to talk about distributed energy sources. So we talk about the introduction of the course, that why do we need this small scale energy sources and what is the benefit. So what was the history of the energy technology, what kind of technology we had up to 2000, and what kind of new technology do we need after 2000. So if I'm going to get back to yesterday, so just can you say that, uh, what is the benefit of this type of a smaller scale energy sources for our society? What is the benefit of this distributed generation technology or a small scale uh, power generation in power and energy society?
We can have like variable power supply.
We can have
A variable power supply.
renewable, you means that. So because variable power supply means that something, the frequency and voltage is not matched with the, so it's like a disturbance.
Means we can like adjust the power based on the requirement of the user.
Yes, very good. Abby, if I'm not wrong, you must buy chocolate, okay? Next session. I will pay it. No, I'm joking, okay? Don't worry. Don't get stressed. I was in a class and I said that, okay, you had the, I mean, in Finland, the problem is that I said that, when you make the joke, you should say, I'm joking, otherwise it's serious. Doesn't matter what kind of actually joke you are saying. So, uh, one of the students came to my class and I said, okay, you had delay, you must buy the chocolate. And I didn't say, I'm joking. And he was absent next session and the other session. And after 3 sessions, I told his friend that, do you know this gentleman? He said, yes. Tell him I'm joking, okay? So please come back. So I'm joking, okay? So anyway, so it means that we can use the local generation, make the balance between generation and consumption. So it means that we can compensate the part which we have the more consumption due to the more industrial sector added to the network, and also the population increase. So then Arya is going to say that, what kind of benefit it brings, like an economical benefit. So cost effective. But why it is cost effective?
because we are not using a large area, and like whatever the
Large area.
generated,
Mhm.
it is just flows in
Yeah,
a
exactly.
source.
Yeah.
System distribution is
Yeah, it means that his means that, we don't need to make the new transmission and distribution line. Am I right?
yes.
Yes. Okay. And what kind of environmental actually benefit? Your name was Navina. Yeah. Navina is going to. Yes. Yes, it's environmental friendly. It reduces the greenhouse gas emissions, and this type of actually a benefit it has. But now, Somi, where are you? Somi, yeah? Somi? Somi. Did you check Somi is equal to, yeah, okay. So, what kind of problem it can be appeared in our network by high penetration of a smaller scale renewable energies?
Mismatch in the inertia.
Hmm. Yes, yeah, it makes some problem. For example, this type of technology cannot provide the inertia. Then, with high penetration of such a converter-based generator, um, we somehow threatening some stability of the power grid. So, excellent. Now we are going to talk, when we said that, I mean, from now we said DG instead of distributed generation, okay? when we talk about the DG, what kind of sources are considered as a DG? So the learning outcome of this session will be at the end of this chapter, you will be able to identify different types of the actually available DG sources in power and energy sectors and explain different topologies for such cases. So when we are talking about the small scale renewable or energy sources, what does it mean? Can you give me one example? A smaller scale. Battery. PV. Yeah, exactly. Local PV generation. So you can install local power PV generation, PV in roof, and then you provide electricity. But when we are talking about DG technology, it doesn't mean renewable only. So if you have a diesel generator, it can provide electricity for your home, and then it can be considered as a DG source. So basically, DG sources are defined for the sources between 1 kilowatt up to 10 megawatt. Okay? So after 10 megawatt, we consider as a power plant. So when we are talking about the DG, first assumption is the power we have or they are available is between 1 kilowatt up to 10 megawatt. So a small battery can be considered as a DG, and also one solar farm which provide support for the distribution company based on the forecast also can be considered as a DG. So So there is a video here, but later I don't know. It's normally doesn't work. Seems not working. No. Okay.
In a conventional power system,
It doesn't have
conventional
any.
power system, the generation of electricity is concentrated in a few power stations.
Hmm?
In a conventional power system, the generation of electricity is concentrated in a few power stations. Distributed generation has emerged as an alternative model to this traditional one. This new model brings generation closer to consumers. The
Can you hear?
development of future electrical systems will be based on the complementarity between In a conventional power system, the generation of electricity is concentrated in a few power stations. Distributed generation has emerged as an alternative model to this traditional one. This new model brings generation closer to consumers. The development of future electrical systems will be based on the complementarity between the two models. Bringing power stations closer to the centers of consumption.
So. What this one? If I use probably let's try. Sorry.
In a conventional power system, the generation of electricity is concentrated in a few power stations. Distributed generation has emerged as an alternative model to this traditional one. This new model brings generation closer to consumers. The development of future electrical systems will be based on the complementarity between the two models. Bringing power stations closer to the centers of consumption is an improvement in energy consumption, since there will be less power lost during the transportation of electricity. Efficiency of the distributed generation system also reduces economic costs,
fix this mic
Mhm.
on this side and keep this.
Conventional power system generation of electricity is concentrated in a few power stations. Distributed generation has emerged as an alternative model to
Is
the
yeah.
traditional one. This new model brings generation closer to consumers.
It won't work. Yeah. Can you call him Vijay? Something.
But it's fine. Actually, later they can change. It's not something complicated. Okay. So you can follow with teaching material.
Okay.
Okay. Yeah.
Energy power stations. Distributed generation has emerged as an alternative model to this traditional one. This new model brings generation closer to consumers. The development of future electrical systems will be based on the complementarity between the two models. Bringing power stations closer to the centers of consumption is an improvement for the environment and energy consumption, since there will be less power lost during the transportation of electricity. The efficiency of the distributed generation system also reduces economic costs and fosters the development of renewable energy. Distributed generation is based on the following energy sources: solar panels on the roof of buildings and homes, isolated wind turbines, which are usually a good complement to solar power, electric cars that can connect to the grid to both provide and consume electricity.
So let's get back again to this.
In a conventional power system, the generation of electricity is concentrated in a few power stations. Distributed generation has emerged as an alternative model to this traditional one. This new model brings generation closer to consumers. The development of future electrical systems will be based on the complementarity between the two models. Bringing power stations closer to the centers of consumption is an improvement for the environment and energy consumption, since there will be less power lost during the transportation of electricity. The efficiency of the distributed generation system also reduces economic costs and fosters the development of renewable energy. Distributed generation is based on the following energy sources: solar panels on the roof of buildings and homes, isolated wind turbines, which are usually a good complement to solar power, electric cars that can connect to the grid to both provide and consume electricity. With distributed generation, electricity demand at peak times can be optimized. It also improves service in rural areas that are a distance from the power grid and in urban areas where the grid is overloaded.
So she said that it can increase the efficiency, and it cannot be. I mean, it was not existed in conventional power grid. Why? Because the conventional power grid are somehow passive. And then the other problem is that or benefit is that it has an economical benefit, but if you mention, they said that wind, solar, electric vehicles, so electric vehicle can be also one of them. Why? Because we have the battery. Does anybody has any idea about the capacity of the battery? For example, Tesla, 40, 2.5, no. Any other idea?
You are talking about the vehicle battery, right?
Yes,
I think 40 to 80. I have heard.
40 to 80. So it's a long, actually, difference between 40 and 80.
Like, sir, it depends on the range as well, right? Now
Yeah.
in India, if you study this
Mhm.
conditions, so accordingly, the average size of battery in Indian electric vehicles is 40 kilowatt hour.
Okay. Yeah, probably this is because of the different vehicles, but for example, Tesla S6 model is up to 120, 30, something like kilowatt. Okay, so it can be very good potential when we uh, allocate this type of technology when we have the peak demand. So when the stress over the grid is somehow very high, then you can use this one as a source of distributed generation to support the grid and reduce the stress over the grid. So it doesn't mean that you need to just inject power to the grid. So assuming that you have actually such a potential in your buildings, so you can actually discharge electricity from the battery and provide electricity for your own load. So by this, you somehow isolate your system from the grid, your load from the grid. By this, you reduce stress over the grid. So there are two benefits for such cases. First, it's somehow a complementary part of the system that you support the grid indirectly. So it doesn't mean that you should inject power to the grid. You can actually reduce load dependency to the grid. So this is one thing. And second is that you as a customer buy electricity when the price is low in off-peak and use it when the price is high on peak. So it means that it has some economical benefit for you. So again, it's dependent what kind of country we are talking. So if we are talking about the China, there is another benefit that you can prove that you provide the electricity for yourself. Then you can get some intensive actually from incentive from the government. So it means that you can provide electricity for yourself, or you isolate your system from the grid when the stress over the grid is high. So, hello, welcome. Yeah. So we have different types of the actually technology for the DG sources. We have some conventional technology based on the actually traditional generator. So traditional, one of them is the actually diesel generator. We had the micro turbine and also low speed turbine. So these type of technology are somehow are traditional sources, but we have also some new generation of power generators based on electrochemical devices like a fuel cell and storage devices. We have the high power and high energy, we can see later, and we have renewable energy, photovoltaic, wind turbine, and a small hydro. Does anybody have any idea about the, for example, fuel cell? Is it good, bad, interesting, useless? So, fuel cell, yeah. So, we will see. But this is just a sample of DG sources. You can see, for example, micro turbine is one of them that can provide power less than 100 kilowatt. I mean, it doesn't mean that only this one. So, for example, here fuel cell mentioned less than 400 kilowatt, but the price of the fuel cell is very high. So, if you find that one, then you should pay lots of money for this size of fuel cell. Diesel generator has this possibility to provide in the range of 1 kilowatt up to 10 megawatt that considered as the DG sources. We have also a small scale and medium scale wind turbine and PV. So when we are talking about the smaller scale, doesn't mean that we cannot have a large actually production. So we can see lots of power plant are close to. I mean, we have some standard power plant in Finland, wind power plant with the range of 750 megawatts. So it is not somehow say that you cannot, but what we are saying that there are some possibility to provide for local loads by this type of actually generation. So now we are going to talk briefly about the fuel cell. You don't need to go through the details of that one, but I mean, fuel cell, one of the interesting types of the generation which can be use as a complementary source or backup source for the some buildings. So it can be industrial, residential, and commercial buildings. And nowadays is a quite hot topics that we provide electricity from hydrogen, green hydrogen, and just store it and then later use the fuel cell for providing the electricity. So it has a quite high efficiency and low emission, and it doesn't provide any noises for example, some office building that concentration is needed. So you cannot actually, it's not like a diesel generator that provide the noises also or pollution. And basically for the electricity, the efficiency is up to 40%. But when we combine heat, also we somehow capture the heat and use for the different application, like for actually some, I mean the heat for the buildings or for some specific application, then the efficiency go more than 85%. So it is very efficient. But there are some still drawback from this technology, especially this, if we don't find actually good solution for that one, then we get in the problem for future. So first is the price. Does anybody has any idea what the price of fuel cell? Yeah. Yeah. Mm. Yeah. Mm. Yeah, but just fuel cell, it is quite expensive. I mean, yeah. Then we had actually project. We had a plan to buy a fuel cell, and for the range of 30 up to 60 kilowatt, the price was 700,000 euros. I mean, yeah, we talked because they had the plan to. We had the plan to use the natural gas for that one. So yeah, yeah. For this case, I mean, the price was very high, but we needed. I mean, we could use as a just a. Yeah, and there is other. I don't know about India, but you know, in Finland, everything is much more expensive in comparison here. Even we had the plan to order from USA, and there also was for 6 kilowatt. It was $90,000. So it was also very expensive. So it is not that much easy. But what the government plan is to reduce the price of the fuel cell 10 times more, up to 2030. I don't know how, but yeah, they are actually planned. Yeah, probably. Yeah, they use the different, but still nowadays is very expensive. But you know, they have some targets, and they are going to meet the targets. So for this, it's a quite good that you know everything goes quite in the right order, and when they make something virtually or in reality, they will meet it. So hopefully we're reaching the point that that we provide with less actually price. But there is another problem that this electromechanical, actually electrochemical devices, they are not too fast. Yeah, so they have a very slow dynamic. Then if you are going to allocate green hydrogen in future system, then network is not in modern system that less synchronous generator are working, and we have a lack of enough inertia in the system, then system will be more dynamic. And if something happening, fuel cell is not fast enough to compensate the or support the dynamic stability of the network. So for this, there are some projects that combining the fuel cell with the supercapacitor, and then supercap actually can support the dynamic part for the high power application, and then in the steady state high energy they use the fuel cell for that. Yeah. But anyway, the weakness is it's very expensive nowadays, and the other problem is it is not too fast. So probably later you're going to think that one you should about the your research topic. One important is that how we can use the fuel cell and provide the stable source of energy for customers. So, I mean the technology. I'm not going to talk too much about this, but we have the input hydrogen. So we have a cathode and also membrane. So we split actually to electron and proton. Proton can pass, but electron follow this direction and provide the electricity, and by oxygen the output can be water plus heat. So this is why we call, probably professor can also explain more about the technology. We call it proton exchange membranes fuel cell. So we have actually this catalyzer here. Just we can actually pass the proton from here, and then electron find a different direction to create the electricity. So the next generation is the photovoltaic, that we can think about the 1 kilowatt up to several gigawatt. But for the local power generation, normally we have this possibility to use the somehow potential of the area we have, and then provide the electricity for ourselves. So it is very important source of energy that we can use. Why? Because it's somehow renewable source of energy. It doesn't provide any greenhouse gas emission, and then we have a good potential. Just 18 days of sunshine on Earth contain the same amount of the energy as is stored in all of the planet. So if you put the gas, oil, everything, you can actually provide as much as 18 days we can get energy from sun. So it is very important source of energy, and it's very somehow economical, and also it can provide electricity up to 31%, but it depended where you are installing. So if we provide actually somehow PV power plant in India, so generation is completely different from Finland. So because the temperature, radiation, and everything is completely different, so we have a better potential in India comparison with the other countries in Nordic countries. So this is very important, but just the example, if you are going to provide 150 kilowatt, then you need actually 4,000 square meter, and again this is not somehow fixed number, because it depended to many factors where you are going to actually install this PV panel, and then somehow provide the electricity. So the operation is also is not complicated. So we normally use the silicon-based PV panel, and when the photon hit the surface, one electron release and provide the electricity. So it is not that much complicated technology, but it is very useful. So we have different types of the app. I mean, we can install in different ways. So for example, this is the conventional way that you can install everywhere in the roof of the commercial building or residential building, or you make a small power plant close to the load center, or also some space that you have available and you need electricity for that one. So this is a little bit more modern, but it's still not too much. And nowadays they find any area that you can use for the harvesting energy from sun, they can actually do this one. And President Trump also in the 5 years or 6 years ago mentioned that it is good that we make the border wall in the Mexican border and then install the PV there to get the electricity, because the sunshine is very good that region. Anyway, so you can actually use the potential to provide the electricity from PV anywhere. But we have also some more advanced technology that maximize the harvesting electricity from this technology. Just one simple example is this. So we have a box for that one, and the reason is that if some storm or something happening, it doesn't hit the PV panel. And it's changing based on the direction of the sun. So we always have the maximum actually radiation to provide the maximum also power. So if the storm or something happen, it can get back again to the box and so it is pretty matched with the, for example, residential buildings. So if you are going to make a, for example, cottage or villa or somewhere far from the distribution grid, this is very useful technology. So recently we had, actually I mentioned at L03 University we have 200 startups. So one of the small startups, they are actually using local power generation for the remote places. They have recently one project to provide electricity for a sauna in the middle of the lake. So in the lake they have a small island that some people go for the actually some fun during the winter. I don't know ice ski or this such a activity, but they make it, I don't know, shop, restaurants and sauna. And the owner of this building requested to provide the electricity 300 meters far from the sauna. And the reason is that they don't have too much space. They have a small space to provide the electricity, to provide this activity. Then it's 300 meters, and then they ask about wind, not PV. Does anybody can guess why only wind, not PV? exactly. Yeah, 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 exactly. So they need for the sauna, and most of the time they such activity they have a hole in the ice, middle of the middle of the lake when the temperature is minus something. They go to sauna and then jump to. I think it's one time I did one time per life is enough for me, but it's a nice activity. So during that time they need electricity. They don't have PV, so wind is much more feasible for such application. And uh, then they provide 2 kilowatt 300 meter far from there to support the just sauna. So but for such a cases, if you have similar activity in India but not this ice, because I know that it's not that much easy to find the ice over the lake in this region. So but probably similar case when we need the electricity, this type of technology, solar can be extremely useful to provide the electricity for remote places when we don't have too much access to or easy access to distribution grid. But again, there are lots of projects all over the world that they use this potential to provide the electricity from the PV. So one of them is in South Africa. So you can see that it can provide 96 megawatt, and then support the 80,000 homes. Does anybody knows that what kind of DG system is this system or this power plant? Yeah, actually, it's like a grid forming, because they don't have access to provide the or be connected to the grid. And the reason is that they are 96 megawatt. They are not distributed generation. They are power plant. So for this case, we don't call such case distributed generation system. They are power plant, but they provide electricity. After I said that 5 years, you see that you just pay for the maintenance. Installation fee can be actually compensated. So it has a lots of benefit for the country. This is why I said that you will be future player in the Finland. So you should consider that. So for India, so you should consider that your country is a rich country. You have a lots of natural resources that can be used, and especially from the PV. Then why not? As Finland somehow declared that we are going to be number one in hydrogen. Why India? Uh, when we have this potential India, why not India become the first one in the PV or one of the biggest leader? I don't know actually, Professor, what is the situation for PV in India? Is it too advanced or? Mhm. Mhm. Supporting. Okay, yeah, it's excellent idea. Yeah. Mhm. Yeah. Yes. Yes. Yeah, this is very important actually. I mean, the important thing is that we have the potential, and then we can use this potential. And even in Finland, when this war between Ukraine and Russia started, so uh, the this Ukraine had the plan to join the NATO, and Finland has the same. So they were in the same side. And then Russia stopped transferring the electricity and gas to Finland, and the price become 4 times more. And then lots of the people actually use the local actually PV. I don't know, 10,000 euros, something like this, and provide the electricity for themselves. And nowadays, when the price goes down, still they feel that this is a very good business. So lots of new job created in the Finland based on this idea. And I can promise you, if you provide such a cases, that because lots of components or technology are much more cheaper available in India, China, and some similar countries. You have lots of potential and resources. So if you provide this one and you guarantee reliability of such system, you can find easily. At the beginning, it's a very challenging to somehow guarantee the system is working well. But if they trust you, you have a plenty of customer in European side, and it's very somehow good business for your financial side. So I know that they are very interested to good job. So it could be somehow interesting topic for your future career. Anyway, so we have different technology concentrating solar power, and this type of technology are, as you can see, we use the actual mirror to reflect the solar to this part. We call it receiver, and we have sometimes like a molten salt with the temperature is 200 and it increased to 600. So this molten salt is coming from this pipe to this storage, and then go through this pipe to the water and provide the heat, steam, and the steam used for the turbine, and then the temperature goes down to 200 again and return back to this storage and go to receiver again. So by this you provide the steam, and like a steam turbine it can generate the electricity. So now I have a question from that gentleman. What is your name, sir? Yeah, you. Asha, do you know what is the benefit of this technology? Why we have this storage here? Why do we need it? Asha, to maintain the temperature. You are like a politician. Say something. I can accept it or reject it. Okay. So, okay, Asha. Sorry, your name. What is your name? No, sir. Roseya. Roseya. So, what is the benefit? Yeah. Excellent. Yeah. So, when they actually reach to the evening, then we don't have sun. Then we can store here and continuously use it during the night. So for this reason, we need the storage here to store and use after sunset actually. Basically is based on superheat. It goes to dependent what kind of technology we use, but it goes, for example, for molten salt it goes to 600 degree. Yeah. But when it's cooled down, then it's go to 200. So by 200 you can provide, but it's not superheat. Yeah. So this is a project in Atacama desert, and if you see that storage can provide 13 hours of the full load storage. Actually here we have 2, and we have also here, and then this is a desert that we have the maximum radiation. So we have a plenty of actually similar cases in USA, but this is for the Chile, if I'm not wrong. If yeah, it's in Chile. Uh, then if you don't use this potential, you cannot use this land for, I don't know, farming or this type of thing. So it is a somehow type of the land that the government use in the most smart way to provide the electricity. And this project also done by Abengoa in Finland, in Spain, sorry. Okay. Any questions so far about PV? Yeah. I mean, basically, in the conventional system, it's not changing. But nowadays, they are trying to actually fix the angle of the mirror based on the actually the sun direction.
So for that, why can't we use a smart clock also?
Smart what?
Like a sunflower,
Yeah, yeah.
rotating.
I mean that one is quite expensive if you are going to go, but now you just fix it and then use the change the direction. You have the sensor for that one, and then yeah, yeah, they have yeah. So, but if we use some that technology, yes, yeah, it's very smart, but it's very fancy also. So it economically will be probably not that much feasible. And then another thing is that such a desert, they are not that much subjected to a storm or these type of things that happen, for example, in some countries like Finland, because in Finland you have plenty of time that we have a storm, or so probably it makes the system a little bit unstable. But here is much more, and USA also is a country that they invest too much about this technology, and the average consumption in USA is 13 times more than the average of consumption in the world because of the industrial sectors. So for this, only rely on the oil is not a good idea. Now President Trump returned back, and then he's not that much actually believed to renewable energy, so the story is different. I mean, basically, this is very good, but it's not enough for, yeah, 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 yeah. And I know that 2006, the government of the Canada started to increase such technology, but then they see that if we use maximum potential from solar, then and also phasing out the nuclear power plant, the gap between consumption and generation was 24,000 megawatts. Yes. So for this, they said that only relying in this technology is not enough. Still, they have also nuclear power plant, and but they made a very big at the first stage was the research to. Beside this one, they optimize the energy consumption with the new types of smart loads, and then maximize the PV, wind, and such cases that help them to reduce the dependency on nuclear power generation. Yeah. I mean, nowadays we have actually power plant based on nuclear, but the government switch more in wind. Yeah. Yeah. I mean, you cannot actually compare Finland with a big country like India, because India is a very big country. We have lots of actually. I mean, the resources in Finland are limited, but they maximize the benefit. Yeah. Then I always say these things. Yeah. But basically, providing the electricity, even you have enough resources and money and everything, but providing the electricity for 1.5 billion people is much more challenging. But I'm pretty sure that you have also brilliant actually researcher and an engineer in India that can handle it. So it's dependent to the mindset. I normally say these things. The doesn't matter from India or from European side. When I talk with the student, I said that I do recommend you travel and spend at least some part of your study in foreign country. But if you don't have any strong reason, return back to your own country, because if everybody leave the country, who build the country for future generation? Yeah, I know that probably sometimes economical situation is better, they can pay more, but uh, this is not very it's important, but it's not actually, I mean, the country is also important. Yeah. So I always encourage you go somewhere, but return back again. Yeah. The sky in the other country is not green, blue, more blue. Okay. Any questions so far? Yes.
Referring this example, where is the electricity transported to? Like
Grid.
this grid, example of this particular this
Mhm.
Atacama region. So
Mhm.
like whatever the energy is produced,
Mhm.
where is it exactly sent?
Yeah, actually, this is the far from the local side, actually the load side. Then this is why we said that probably later we will talk about the grid forming converters. I'm not sure that you know that one or not, but you at the end of this course you will see. Uh, then it reacts like a power plant. Then we have actually a transmission line. Actually we send this power to the close to the consumption loads side, and then we have distribution grid and distribute between them. So it depends, but I think that it here is mentioned somewhere. It's like a 60 something kilometers. Yeah. Okay. Yeah. 60. Yeah. So for this reason, I mean, it provide if you buy, it's if I'm not wrong, it was 700 hectare for the PV cell, no, for the mirror, and 300 for the PV actually, PV panel. This is a part because this is a combination of the this thermal base and also PV base. Yeah, so it's a complex combination of the actually two. It if I'm not wrong, total area that they used was 1,000 hectare for 212 megawatt. Yeah. So if you're going to buy such a land, the price will be extremely high, and in some cases it's not possible. It's impossible. So the best is that you get somewhere that the land is not used for the leaf or for the farming, and it can be actually useful for providing the. Yeah, it depended, where you are and what kind of possibility you have, not just in the energy. Do you know what is the most famous part of the world for providing olive oil? Olive oil. Do you know what is your name? You, Jay. Yeah. Do you know where is the most? Thailand. No, it's in Spain. Yeah. And do you know? Uh, Probably it's happened recent year that they get the first place. And the reason is that I was in 2010. I was in the. They have two historical city, Cordoba and Granada, and I traveled there and I saw just the desert, just the mountain, nothing. But last year I went again the same direction, and I saw the government just plant 50 million olive trees. 50 million. Yeah. And then after less than 10 years, they get the position as a first country for providing the olive oil. I'm not talking about the best, but this is one of the best and biggest. So the reason is that they had such a potential which using this way. So if you have any potential to try to maximize this potential and get the maximum benefit. So it can be in India, it can be for wind, solar, hydro, anything. But this is important that you have this mindset that in future we need this one. Anyway, any question? Yeah.
This part is in South Africa. Is a desert.
Can you?
South Africa.
Yes. Yeah. Yeah. Yeah.
They have a desert.
Yeah. Yeah.
So they can play this thing.
Yes. Yeah.
Like India and other countries, they are agriculture land.
Hmm.
So such projects are not possible in India. But PV, like regarding PVs, I want to explain. Like we have like in India now there are some certain companies which are coming in front, and they're providing PVs
Hmm.
in EMI basis.
Hmm.
Like they are installing free of cost
Yeah.
to a big society.
Hmm.
They are targeting a big society, and then they install it.
Hmm.
And whatever we are paying to the provider, right,
Mhm.
electricity provider, we have to pay them
Hmm.
to this company.
Okay.
And
Like a
for the
pro.
5-year duration,
Mhm.
3-year duration, that is decided by
Mhm.
the company, the agreement between the company and the
Yeah.
society. Now, these trains are there in Mumbai, Pune, and rest of Maharashtra,
Mhm.
rest of India. So, like these things are happening.
Yes, it's
Even we have these solar fields across Karnataka
yeah.
and few part of Maharashtra.
Mhm. Yeah, I mean, basically, this is not the only technology that we are, but we are responsible for the future. Yeah.
One more thing is hydro power, right?
Mhm.
Hydrogen cell.
Mhm.
For that, even we have nuclear power.
Mhm.
Those are like for India, there are many threats.
Mhm.
So obviously, people are not going for that technology
Yes.
immediately.
Yes.
Like even Pakistan, your country,
Mhm.
and the subcontinent,
Yeah.
they are not directly jump to that because of that threat only.
Yes.
And there should be a policy for this, and it takes a long time
Mhm.
because you can't put nuclear or hydro types of grids
Yes.
across the country.
Mhm.
So then you need some regulations.
Yes. And Chernobyl also.
That's the most challenge for us.
Yeah. Yeah, I mean, basically, I'm saying that this is why we talk up to 2000 and after 2000. Yeah. But, you know, this type of technology, I mentioned that, you know, if you have such a potential, you can provide. But otherwise, you are discussing a small scale power generation. So there is also such a potential to provide the electricity for yourself. So this is why the government of the China said that you can provide electricity for yourself, and we encourage, we pay you, but because of the grid code, you are not somehow eligible to provide for the electric or inject for the electricity. But basically said that, you know, if you stay in your home, nobody come to uh, pick up you. You should actually find the solution for the problems, and this is the responsibility of the current generation to think about the new future generation. If you said that we don't have actually such a potential to provide the power plant in India, I don't believe it, because I mean, potential in India is very, very high. And if you could not actually make the solar power plant in India. So which part of the world you are going to do?
No, no,
Okay.
we have fields.
Yes.
Solar fields.
Hmm?
PV solar fields.
Yeah.
So many solar fields are there
Yeah.
in mid of the India.
Yes.
Like Karnataka,
Mm.
Maharashtra,
Yeah.
Nagpur.
Yeah. Mm-hmm. Mm-hmm. Yeah, it's very big. Yeah. Yeah. Excellent. This is why I said that, the potential is very, very good, but also you can think that, I'm not going to advertise something, but what I can say that, you have such a potential. You can create a business in India with cheaper price and sell it in the Europe with, yeah, better benefit. Yeah. So, any question? I mean, it depends actually. I really don't know which one is more efficient. Mm. Yeah. 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 Yeah, this is the technology, but I'm saying that it depended that what kind of technology are more efficient or what kind of potential. Uh, it depended where you are going to use. So, for example, this CSP you can use here. Mhm. Yeah. Yeah, this is why I'm saying. Mhm. Mhm. Yeah. I mean, the most important things that we need for such a technology is that this technology is not that much efficient or useful when we have a cloudy situation. But for the PV is partially can still provide. So this is one thing that they consider. In Iceland, they try to dig the land and go. They mention each 100 meter, the temperature increase 1 degree. So when they reach close to 10 kilometer, the temperature pass. I mean, in Finland, they said that after 7,500 meters, the temperature goes 126 degree. So by this, they could use the geothermal and provide the electricity for the heat for the buildings. And in our university, they spend a huge amount of the money uh, to dig the actually land and go inside. It was a case study at L03 University, and the target was 7,500 meters. But when they reached to 6,000 meters, it was some stone, and they said that it could not go more. So they actually shut down the project. I think that they spent uh, probably several millions euros, but then they decided to stop it. So that potential was not existed there. And one other problem of this technology was that because it absorbed the heat from the soil, then after 20 years the soil will die, and then all the plant will also die. So it was not somehow sustainable technology we could use. So at the end, the government say that the best technology based on the situation of the country is that we provide the electricity from wind, and then we have actually can use the PV. And the reason for PV is that we have a short uh, day during the winter, but we have very long, yeah, sun during the summer. It's more than 20 hours. So by this, again, government think that it is better that we find a solution to store this one, because you cannot provide the electricity from the PV during the summertime, and we say we don't have anything during the winter time. So this is why they put the roadmap, this green hydrogen technology in the roadmap to provide the hydrogen, store it, and then use during the winter time. Yeah. Yes.
Sir, in this technology,
Mhm.
too much reflectors are being used and the temperature is being, energy is being
Mhm.
captured.
Yeah.
Sir, can we do a, what you call, control?
Basically, without control, it's not possible. So definitely, this is important. But what I can say, for such technology, the most important is we have actually very strong radiation. So for this reason, this is probably can be used some part in, I don't know, Atacama Desert or in Nevada or something in USA. But this PV panel can be used everywhere. Even in Faroe Island, 7% of the electricity in Faroe Island is an island in the middle of nowhere. But still they have this potential to provide the 7% of the consumption from PV. Yeah. But such a case doesn't work. This type of technology is not feasible in some even central part of the Europe.
If this is the thing, we can directly put on window package.
Yeah.
So that we can consume the entire, that building can be consumed, energy can be used from this.
For the, building, I don't see that much actually. Probably you can use for the some specific application, but if you are going to use for the electricity by steam and this type of actually production is not. It's like yesterday I said that you can go to supermarket by truck or by like a passenger. This is possible, go to supermarket by truck, but it is not actually efficient way. Assuming that 7 people go by truck in the supermarket, then you have traffic. Yeah. So
The government is encouraging high-rise buildings.
yeah.
Some towers, 30 and 30 floors.
Yeah.
So we have to mandatorily install those PV modules.
Definitely. Yeah. Yeah, this is even in some third world country that still they try to do this because of several reasons. It's feasible also, but it depended that where we are talking. So in the building, just like apartment building, even we have actually some electricity to support the corridor line. This is also very useful. And you can put the PV panel in the roof and then use it. But this CSC should have a very somehow continuous actually radiation to provide the electricity. Biomass, yeah. Yes. Yeah. I'm not sure this is correct or not, but I heard also that because in some region there are lots of elephant and this type of biomass can be also provided by, I don't know if it's correct or not, but I heard something from somebody. Is it true? Yeah. Yeah. I'm not sure. Because nowadays, we must actually use the different technology to take care of our environment and also our resources. So I hear it, but I'm not sure that this is correct. Yeah. Okay, yeah, nice. So, this one, it depended to radiation. So the efficiency can change between 5% to 40%, but it depended, you know. Yeah. Yeah, this, yeah. I mean, basically, we need water also, but it is not that much. I mean, it's for the more for the maintenance stage. And nowadays also they use because assuming that this is 300, no 700 hectares, and a fault happening in one of these mirrors. So how would you like to actually notice? Nowadays they are using the drone to monitor drone for the monitoring the system. Yeah. So by this they are going to somehow reduce the risk from the fault or this type of, or at least they can detect it faster. But all in all, we need a lot. It's not just we implement this technology and just get the electricity. No, we should consider also this production. Yeah.
So what type of control they are using?
Control. Come on. So I said that you are controller. That's enough for you. Yeah. I mean, no, basically, let me give you the right answer. For the other projects, because I was working in this project 6 months, so I have just a general information. They use this SPC technology, and the company, they call it Gema, but here in Spanish they call J. They pronounce K, and the Finnish also say Ye. So Gema company or Gema company provide the converter, and the converter was 1,000 megawatt. So it was a combination of the 3 parallel converters. So each converter had the capacity 350 kilowatts. So when the radiation changed, I think that when probably reached to 35, so the radiation in 9 a.m. is different from 10 a.m., 11 a.m. and 1 p.m. So when we reached the 35% of the capacity, then second converter connect parallel with the first one, and then when it passed the 65, third one also connect. So the technology they used was this parallel connection for this project, and then they used the SPC, synchron power controller. And if you are going to know more, I can explain with details probably in chapter 5. But the reason was that in SPC, the model that they used was based on the admittance of the system. So if instead of actually providing the somehow derivative, you have LR, okay, LDI to DT. So when the converter passes the current, inject the current, it takes the derivative of the current and it increases the somehow disturbance. So then they decided to change the voltage control to current control. Instead of impedance, they use the admittance of the system, and this 1 over L di to dt plus R work like a filter. Instead of increasing the disturbance, it filters the disturbance. It's a very smart actually technology they use it. But we will discuss about the details of this technology later. So it's enough, or we can, I'm okay, we can continue, but it's fine. Okay. Let's have, some break and then later continue. So wind is also very interesting because we can provide a huge amount of the electricity from wind. But we have also this possibility to provide from wide range of the actually production from couple of kilowatt up to some gigawatt also. So it's a very interesting because we can make the plant for longer duration, and the installation cost is quite expensive, but you can get the lots of power and it can be compensated fast. And it has some limitation. For example, if you are going to provide the electricity, the speed of the wind should be at least more than 3 meters per second. And also somehow this is very useful technology when you are going to provide electricity for remote places that transmission or distribution line are not that much easy access. So also the problem for the hydro and this type of technology are not needed for this production system. And also it is based on renewable energy. It doesn't provide any greenhouse gas emissions. So basically very nice technology for providing electricity for our system. So this is just a sample of some a smaller scale generation from wind. So it can be even 400 watt up to 5 kilowatt also for the residential building can be used. So it is not that much complicated, but the problem probably is regarding the diameter of the system. So if you are going to, for example, provide such a case or this one for a residential building, the diameter is 6.4 meters. So it is not that much easy said that in the, I don't know, my residential building or in the terrace of my apartment, I'm going to install this one and provide electricity for myself. But all in all, the feasibility for providing electricity from wind is highly efficient and also high demand. So just briefly, I'm not going to discuss with details. Later we get back about this technology, but basically permanent magnet synchronous generator are used for providing the actually electricity from wind. So because the speed of the wind is not constant, so what we are providing is like this. So you cannot actually use this one for the load because we need to have the high quality power with the constant frequency and voltage. So for this case, we need a rectifier here to change the this AC power from AC to DC, and then we need the regulator to here. So for example, after this part, you see that we have a little bit fluctuation here, but we use a voltage regulator here. We regulate the voltage to 800 volts, and then by use of a DC AC converter, we convert the DC to AC with 50 hertz frequency and also match with the voltage of the grid. It can be 400 or 20 kilovolt based on the standard of the country. So we normally use, even we consider this is like a, I don't know, 5 kilowatt. Still we cannot use it for the transmission line. Does anybody knows why? So we always said that this is the close to the load center. So load is normally connected to the distribution grid. So why we don't say that this is not for the transmission line? Voltage and frequency, but transmission and distribution have the same frequency, but the voltage level is different. But even distribution also voltage level can be different. But the main reason, does anybody has any better idea? Sorry? Based on what question?
Please repeat the question.
Uh-huh. I'm saying that, you know, this type of generation, for example, 5 kilowatt up to 10 megawatt, they are distributed generation, and we can provide such electricity, but we can use this electricity for load centers or supporting the distribution grid, but we cannot support transmission or inject transmission grid. Does anybody have any idea why we cannot? No? High harmonics, inertia. Inertia is good. Harmonic is bad. So, more explanation, idea. Arya, do you have any idea? Is your problem? I can't pronounce your name easily, so this is why I said, yeah. Okay. So, I ask your name, but I can use a different way. Arya, do you know him? Yeah. What is his name? Siddhan. Okay, Siddhan? Yeah. So, do you have any idea about why we cannot use this one for transmission line?
Basically, in distribution system, the other devices are get connected to that,
Mm-hmm.
so that the power supply get skips, so the devices does not cause any harm. So that's the reason.
Mm-hmm. Let's see another one. Okay. Power loss is, yeah, okay. No, I mean, basically, the main idea for the local power generation or uh, uh, this type of distributed energy sources is one aspect is losses. But the question is that why we are not allowed or we cannot actually inject from this converter to transmission line. So for example, if we have a source like a 5 megawatt, but we have only transmission line, then they said that no, absolutely no, I don't care actually you provide the 5 megawatt, but you cannot be connected to transmission line. Okay, the answer is that this type of technology, converter-based technology, we call it custom power technology, they are designed for distribution level, okay? So these are not actually components for the transmission. For the transmission, we have different technology. We got flexible AC transmission system, so FACTS devices. So the components for transmission are different from the distribution. So you cannot say that, you know, I'm going to provide electricity and then by connected to this the distribution transmission line. Okay, but then the question is that, so why we provide electricity from wind or solar and then transfer it by transmission? Because we cannot, for example, in Atacama project, we had 65 kilometers far from the load center, so it could be by transmission line. So then Edris told it is not possible, but we need a converter to provide that one. So it's a little bit contradiction. Am I right? Yes, Arya? Yes. Okay. No. Yeah. I had a student like you and said that sometimes said yes. He said yes. I said but sometimes no, and then sometimes yes, sometimes no. Okay. So you're like this. Anyway, okay. So this is true. I mean, this type of generation, we need always converters. And the reason is that we should, nature of the generation are different. So for example, fuel cell provide the DC PV provide the DC, wind provide the AC. Then based on where we are going to use, we should change or match the nature of the generation with the consumption. So the nature of this generation, wind, is AC. And the nature of the grid is AC. Okay? So we should match the voltage and frequency of generation match with the frequency of the actually distribution. Okay? But for the transmission, we provide electricity. So assuming that we provide the electricity here. Then we provide actually DC line here and then converter here. Then we have actually between transmission and distribution, we have actually power station. So it changed the actually system. In fact, we use the power station to integrate power plant to transmission line. So by power station, we use the transformer. We increase the voltage level to several hundred kilovolt. And then by transmission line, we send the power from the generation to the consumption side. So you can provide the electricity, use the converter, regulate the voltage and frequency, but you cannot connect it directly to transmission line. And this is so if someone asks you what kind of the voltage do you have here, you should say that I don't know, but it's a distribution line. So it can be, for example, 20 kilovolt. If I'm not wrong, in India, it's 20 kilovolt, yeah? Is 11, yeah. So I mean, different country, yeah, have the different. Yeah, okay. Yeah, in some also country, 11 and yeah.
40 kilovolt transmission they have.
40?
400 kilovolt.
400, yeah. 230 and 400 normally for the different countries for the transmission. 11 and 20 for the, yeah, for the distribution. Anyway, so we have also micro turbine, and this is very popular source of DG. So you can provide the electricity for local loaded. So it also provide up to, I don't know, 300, 250 kilowatt. And the main part actually, for example, in USA, in Texas and this type of actually the storm happening, then the American distribution or transmission line are not that much strong. So basically this type of technology is extremely popular in USA because it can be used like a small generator for them, and they can actually have access to electricity when this type of a storm happening. And next is battery. So we know that we are talking everywhere about the storage devices, battery, and we have two different categories for the battery storage. So we have high power technology and high energy technology. Does anybody know what is the difference between high power and high energy?
Batteries have high energy density,
Mm-hmm.
and supercapacitors have high power density.
Mm-hmm.
Supercapacitors can instantly charge and discharge
Mm-hmm.
little time. Batteries will store discharge slowly. So they have energy density, and supercapacitors they have high power density. And with the combination of both, we will have high efficiency.
Okay, good. Excellent. Thank you very much. So we have two different types. We can say that high power and high energy. High power like supercapacitor. As you mentioned, it can be charged and they charge fast. But high energy is like a lithium-ion battery. You can charge it and discharge, but it's not fast enough. I mean, lithium-ion is medium level, so but in some technology like fuel cell is even slower than the lithium-ion. So for this case, when we are actually talking about the technology, then we said that we have battery. So, when we are talking about the system, so assuming that you have a grid here like a three-phase system, so it has the impedance of the grid, and this is the load we have here. L1. So then you have actually a converter here that provides the electricity, AC, DC. So we have actually DC bus here, and there are three-phase also. So it can be like this. The frequency of the system is 50 Hertz. Then we're reaching some peak time, and L2 is also, or the load increase, and the frequency fluctuating a little bit more, which we don't like it, and it's coming because of the stress over the grid. And then we used actually this storage to provide the support to the load. So then if we have, for example, 10, which increased to 20, and this 10 is injected, but you see that, 8 is added, so we have 18, and then we have 2 from here. So 2 plus 18 is 20 KCL, okay? But what is happening is that, when we have load, it's slow, it's fast. Okay, when this fast changing happening, and we have like a lithium ion battery, then it cannot supply the load changes so fast, because we need to pass this transient and reach to the steady state. So for this case, we have a transient stability problems, which is not good for the sensitive loads. Because these sensitive loads, like a computer or some other technology, which probably computer is not just playing with the game or like this one, so you can use for the programming or also monitoring lots of other things. So they can tolerate the disturbance for half a cycle. So it takes, in the best situation, takes one cycle is 20 milliseconds. So for 10 milliseconds, it can tolerate this turbulence. So if we consider the frequency 50 Hertz, so TS 50, and F is 1 over, sorry, F is, T is 150. So it's 20 milliseconds. So for 10, half a cycle is 10 milliseconds. And 5 milliseconds goes to the detection of the, so we have actually 5 seconds to react, 5 milliseconds to react and compensate the transition. And this lithium ion is not fast enough to compensate that part. So for this case, they used actually hybrid energy storage combination of high power and high energy technologies. So it's like this one. We use the lithium ion, and then we use the supercapacitor. So we have a DC-DC converter, and we have a DC-DC converter. So we provide the DC bus here, and based on that, we have a DC AC and provide the grid voltage here. So when the turbulence happening, we go from this direction, and we are a steady state, we go by this part. So we call this long duration support, we call it high energy. This type of actually technology which can support the power for load or for the grid for longer duration, we call it high energy. And some type of technology which can provide support for the high power or changes, they are fast, but the capacity is not too much, is high power technology. So just the example, supercapacitor, high power, lithium ion. Yes? Yes. Yeah, we have also here, somewhere I mentioned it. I mean, none of these technology are not mature enough, actually. Yeah, yeah. So, but we are developing. So, for example, nowadays we use the lithium ion for the electric vehicles. But do you feel that they are mature enough? So, can you compare the Tesla is better or Mercedes-Benz EV? Which one is better? Why? So, now the competition is that Mercedes can go up to 1,000 kilometer when full charge, but when you use the Tesla, it goes to 500. But there are other things also. What is the weight of the battery? What is the size? What is the price? And this. So what they are doing nowadays is that they are going to optimize first the structure of the system, and second is that then by this they can, when the losses reduce, in fact you can optimize the size, weight, and cost. So just a simple example. Let me get back to this whiteboard. Supercar. Yes. But I mean, when we have actually this protection, yeah, definitely, yeah. It's very important actually. So when we are talking is like a ideal operating condition, but definitely we should consider. So, just a simple example. Assuming that you have a lithium ion here, yeah? Li-ion. Yeah, then we have also supercap here. So we said that we need a DC-DC, and we have also a DC-DC, and then we have a DC bus, okay? So it doesn't matter what happened there. So, Udaya, tell me, do you like this structure or not? Assuming that you are going to, because this structure is used for the heavy duty vehicle, combination of lithium ion and supercap. Do you like it? Yes. How much you like it? Too much? Okay. Okay. So now I pay you 1,000 euro to provide something better than this, to increase the capacity of the system and also somehow compete with another company that use this technology? Do you have any idea? Different structure? Mm-hmm. 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 Yes.
That is one thing that I can propose. But the other technology, more than
Yeah.
that will be more than.
Is off. Yeah.
Yeah, more than that, I can't say as of now, but this is also not at coming to the phase with the industry to adopt this one. It is
But
still
this is the adapted technology in heavy duty vehicle.
heavy duty.
Yes.
But we are not aware for the two-wheelers or of some three-wheelers.
Mm-hmm.
Yeah, this is one okay. Means like I can say that it can enhance the battery and protect the battery against the falls.
Okay. So it means that I, as the owner of the company, cannot pay you 1,000 euro
Mm-hmm.
because you just approved that this technology is good.
Technology is good.
Is good.
Yes.
You like it.
Yes.
Okay. Is there anyone to say something different than I give 1,000 euros as a, yeah, honestly I give. Okay. I had an Indian friend and I didn't have the currency and he gave this in, remind me like a grandmother actually. So I give this one in my pocket. I bring it from the Finland. So, Arya, motivate you? No. He's not looking for the money. He's looking actually for the different things. So, you, any idea?
So you are talking about source only, or the load can be DC?
No. I can say that, you know, this is the technology we are using the electric, in my company I use for the electric vehicle, okay?
Other than
Why? Because I'm going to drive, but this heavy duty vehicle at the beginning, it should actually get some acceleration. We need actually something high current, so it can be supported by this, or when I'm driving, then I'm going to pass somewhere. But then later, for the longer duration, I use lithium ion. And by this full charge, I can drive 10 hours. But my concern is that in 10 years later, my competitor company developed the technology with 12 hours, but the same price and the same size and everything. So this is my concern. Do you have any idea that, you know, probably with the same structure, I developed something that compete with this company and still have the first place?
So you need both in after 10 years or something.
Yeah.
Mine and super I can change capacity.
Capacity, but the problem is that if you increase the capacity, then the size increase, and then
one more thing, without increasing, that I can.
Size,
Yeah.
as I know, is 10 times less.
yes, but the problem is that you cannot use for longer. Yeah, this is the problem, and the price is also high. So this is the problem. So
Yeah,
Udaya?
one more thing that we can augment one more distributed generation like PV panel we can make use that it also.
Definitely PV panel is also very
And
yeah, very hot topic nowadays. Basically, they say that, you know, we integrate PV. Today is the 4th of February, so it's the deadline. European project we have.
Okay.
And it's we use the PV in the roof of the electric vehicle to somehow support. And the benefit is that one passenger vehicle charge 66 times, but with this PV integrated system, you can reduce per year also. You can reduce the charging to 38 times, they said. I mean, this is I mean, probably is a little, but you can reduce the but you cannot fully charge your system, just rely on this technology. So it can optimize. But anyway, that one is different story. I'm now talking about this story because we are engineers. Battery management system is getting back to the control, and control can be, because we have three different types of actually optimization. One is based on the control, second is based on the structure design, and third is the material. So for example, you can use the silicon or silicon carbide. Which one is better? Silicon carbide. Okay, so now again get back to this one. I have 1,000 euro I'm going to give to someone. So except the professor. So I'm assuming that he give the right answer, and then I should really pay. So any idea?
Sir, to increase the efficiency of battery life, we can use the regeneration mode, like on any slope.
Did I ask about the life of the battery? Did I ask this? I asked about this duration, not the life cycle.
No, I was talking about duration.
Okay, tell me the duration. So you say that after 1 year, when it's some problems happen, and then we can use that one, still keep the same life cycle or duration.
No, actually, it is not for after that few years the battery duration gets it actually decreases.
Mm-hmm.
I am talking about in consistent mode if the vehicle is running,
Mm-hmm.
so that if we decelerate the accelerator, on that basis the energy taken by the vehicle is used by the regeneration mode.
Mm-hmm.
Actually, regenerative braking.
So then it's better.
Yes, it will be better.
So it will be more duration for the driving, and also, okay, for sure? Okay, let's see. I can give 100 euros for you if it's correct. Yeah, okay. So any other idea? No? So I'm not going to say that, we should know this one. I'm going to say that we are engineers. Always we need to upgrade our system, and system should be,
Energy density of lithium ion should be improved.
yes, this is something that we should consider, and yeah, and the technology is
Solid state batteries.
yeah. But when we assume that we have exactly two technologies, then three important things is the structure, control, and the material. So if we get back to these things and said that my system is mature enough, but I'm going to develop it. It means that I get a good feedback from the customer, but my concern is that my competitor can provide something better. So what I do is this one. I said that in a state of actually, because when we charge this package, we charge the lithium ion, and then we convert the DC voltage, so we have one conversion here. Then assuming DC-DC converter have 95%, 93, sometimes 98, something like this, but we have, for example, 5% losses here. And then again, we come here, 5% more, we charge the supercapacitor. And then when we use it again, we use this supercapacitor again, another conversion, so 5% again here. So totally we have 15% losses from here. Okay, 3 stage. So I'm engineer, I'm smart, I'm the brilliant, I got my PhD or bachelor or master in NIT, so I said that in a state of go 3, I'll go directly from here to here. DC, DC, okay? So what happened? We charge this one 5%, And then they charge this one 5% also. So instead of 15%, now we have 10%. Okay? This is the structure design. And the other things is that control. So what we use in battery management system is the old version, but we are not going to use the same technology for the future. So for example, when you use the PWM for the control, you have a structure, switch it, and it provides based on that signal for the converter, and then. But nowadays they said that we use the predictive control. So predictive control said that I choose the switching based on the optimal operating condition to minimize the switching losses. Later we see this one. So then control of the converter also can increase the efficiency. So nowadays if you use the PI controller, is the efficiency equal when with the AI-based technology or machine learning based or predictive based? If they are the same, why do we need to change our controller? So one efficient way is to change the controller. So if we use a different controller, then we can reduce loss from 5% to 4% or 3%. Okay? So assuming we had 85% for 3 converter, but now we have 2 conversion, and instead of 5%, we have 4%. So we have 8% now. Okay? This is another benefit. Then I use the silicon carbide, silicon technology. Assuming that the silicon, if we change to silicon carbide, what is happening? This material have the less resistance and also is somehow more lighter. So why I don't use the silicon carbide transistor instead of silicon? What is the problem of the silicon carbide? Price. Yeah, it's more expensive, but for longer duration it makes sense. So for this case, we can also optimize. Just give you one example. Some Power is a power electronic company. They mentioned that the losses, they use the silicon carbide instead of silicon for the DC-DC converter, and they said that the losses is 75% less than the converter which use the silicon. So assuming that we give 50% less, so it means that by using this silicon carbide, we can reduce the actual losses to 4%. Okay, so we reduce from 15% to 4%. So it means that if one full charge battery could reach 800 kilometers, now by this technology we can go to 960. Okay, but let's say another things. I said that I provide 800 kilometer duration with the same structure actually, but it means that if the pack is that size for the first 85% actually efficiency, for this technology the pack will be smaller. Why? Because we optimize the losses. So by this, when losses optimize, size optimize, weight optimize, and if you paid, for example, 2 kilos for something, now you pay 1.5 kilo. So it means that the price is also optimized. So you can deliver your product in 2 ways. First, that the price of my final product is less than your product. This is, or with the same price, the duration of my battery is more than. It's like a competition between Tesla and Mercedes-Benz. Mercedes-Benz said that my vehicle goes to the 1,000 kilometer with full actually charge, But Tesla said that 600. So I said, okay, if the price is okay, I prefer to go for Mercedes. No, which one you go? No, I go for Tesla. Okay, it's more beautiful. No, I go for Mercedes-Benz because, you know, it's more efficient, so why not? So this is our mission. You are engineer, you should think about engineer. No, if you ask my father, he's not engineer. I mean, he's engineer, but he's not electrical engineer. So if you ask him, he said that, okay, there are two batteries, but then the duration is this one better, so I go this one. But he doesn't know that, you know, if it is optimized or they cheat with you. Because they can increase the size of the battery, weight of the battery, and then capacity increase, and then it goes more. But I see that, you know, how much I paid for this battery. If I paid the same in these two cars, so makes sense that, okay, go for that one. But if they said that, no, you know, we reduce the quality of the car, but increase the capacity of the battery, so it doesn't make sense for me. Because I'm engineer. I should think like engineer. Okay? Good. Any other question or concern or yeah? You have a PhD in hybrid energy storage, so don't ask this. I know that what you are going to ask. So this is the simple example. Don't make my life hard. His PhD topic is hybrid energy storage. Okay. Any other question? No. So this is why I'm saying that, you know, it is important that you learn the basic and then you do something feasible that or applicable in the real system, and after that you develop the model. So you cannot jump from the basic to advanced level. Go one by one. And this course at the end is completely different from the beginning, what we are discussing. And we learn together, okay? So let's see. Any questions so far? No. Yes.
What are the different reasons for fast and slow oscillation in the system?
Different reason. I mean, the grid, it depended what kind of grid you have. Okay, so if we get back to the power system go to the more renewable. So this conventional synchronous generator in the power plant, they are connecting in parallel together. Okay, so in parallel connection of the system, the impedance is connected parallel. So if assuming that you have 10 generator connection together in parallel, okay? So Z is Z over to 10. So when you increase the generation from renewable energy, in fact, one by one they decrease, okay? So assuming 10 goes to 9, so Z from over 10 goes to Z over 9, Z over 8, Z over, as much as the renewable energy increase, this conventional decrease and the impedance also increase. So when the impedance increase, it in fact the voltage changes will be more affected by the load changes. Okay, so assuming that, you know, you have a grid. So you have this grid, okay, grid. And this is the impedance of the grid, Z. And this is load. And this is the point of common coupling, actually. A connection between load and generation, okay? So assuming this is 10, and the current is also 5, okay? So the voltage drop is 50 here, okay? And then if it is, I don't know, 400, the voltage is 350 here. Is it true? So now we have a similar grid, which Z is 1, and then this is 350, 90, and this is load. Okay? Which one is better? Which grid is better? 390, yeah? Why? Because the standard level is 400. And the voltage drop is here is 10 volt. So we don't have too much losses. So any changes in this system, so if I have another load, it changed the voltage too much. So the voltage is unstable because it's fluctuating based on the change of the load. But here is not that much actually. So the grid is stronger. The voltage is not that much affected, so we have a quite a stable volt. Did you get it? So if this type of things, this type of network we have, then this type of actually fast system is not needed because the system, the grid damped the fluctuation. But in future grid, we know that we have more power electronic based generator and less synchron generator. So we can actually predict that future grid is not as strong as we have now, this synchron generator. So then it will be more dynamic. This dynamic is coming because of this. And then the other problem is that this type of synchron generator, they are very stable. They provide the very stable voltage, but converter, they have just a switching mode, which is not, you cannot predict the behavior of the converter. Is that the dynamic reaction is not predictable. So for this, they also provide some disturbance for the grid. So future grid, which are dominated by huge number of the converter-based generator, they are very actually sensitive to the dynamic changes. So this is why we need a technology to support the grid and reduce the dynamic reaction in the system. Yeah. Any other question? No. Good. So now we pass the history of the distributed generation technologies, and now if someone asks you about the electricity history, what happened, you know that what happened from 1880 up to 2000 and after 2000. And now we know what is the distributed generation technology, resources, and then we know what kind of benefit it can bring for us, and probably it also provides some challenges. We said that it makes our grid with less inertia, and when we have less inertia, Abe is here? Yeah, okay. Always remember, when you talk about the inertia, I touch him, and he was very high inertia, didn't change, but I have less inertia, I fall down. So this is the example of the inertia. Anyway,